Everybody, this video is about the physics journal entry about vector components. And so the question that's guiding us today is how do you give walking directions in a city? Point being is that in a city you can only walk right along blocks. Not very often do you get to walk the diagonal. So if you wanted to get somebody from here to here, what kind of directions do you give them? So diagonal vectors can be thought of as a horizontal vector plus a vertical vector. So a reminder to you is that a vector is just something that has a direction and a magnitude. So the direction would be the direction the arrow points. The magnitude would be the length of the arrow. So in this case, we have a vector that's supposed to represent probably velocity with this v here. So maybe the velocity is kind of like up and to the right. And so we could break that into a horizontal part of the velocity and a vertical part of the velocity. These are called x and y components of a vector. So here's here's our velocity v, and here's angle theta, and so this would be our horizontal component. This would be the vertical component. So we're going to be using this mostly with forces as we go into this unit. But we're just using it with velocities because you're familiar with velocities. So this basically makes a right triangle, right? So we're just going to have to review some trigonometry, meaning some sine and cosine. So if this is a triangle, this would be where the right angle is. This would be, your angle could be either here or here. And so provided it's right here, then this right here, the velocity vector here would be the cosine part. It's the adjacent side. Adjacent meaning next to the angle. So the adjacent side is found with cosine. The equation for cosine is cosine of theta is equal to adjacent over hypotenuse. So adjacent would be the part next to the angle, the leg next to the angle. Hypotenuse would be the longest side of the triangle. So for this part, it would be the velocity in the x direction divided by the velocity, um, the total velocity, which would be the hypotenuse. And to write, in this case, and almost always, you are given the hypotenuse, you're given the vector itself, and you're trying to find the two legs. So you can multiply the velocity over here. So multiply both sides by the velocity. That's going to tell you that Vx, the x component of the velocity, is equal to V cosine theta. Y is the opposite side, or Vy is the opposite side. Same sort of process, you would use the sine function for that. Sine theta is opposite over hypotenuse. So that would give you Vy, the opposite side, over the hypotenuse V. Just as before, we multiply both sides by V, and that's going to give us that Vy is equal to V sine theta. The y is not always the sine. It depends on the angle you're given. So if you were given, let's say, this angle right here, it would be it would be opposite. So just realize that, it's often this case, like probably 90% of the time, the y component is sine and the x component is cosine, but it's not always that way. So just be aware. We continue to use the same coordinate system that we've been using. So vector components can be negative if they point in the negative direction, which is generally to the left or down. So that's that. Okay, let's go ahead and take a look at the example problems here. So here are our example problems. So our example says a drone flies a package 1,300 meters at an angle of 35 degrees north of east. So what that means is north would be up. Think of here's north, here's east. So 35 degrees north of east would be right north of east. So anyway, either way, I drew you're not going to get directions that often that are like that. So I drew you a diagram here either way. So we're trying to find how far east we go and how far north we go. So First question is how many meters east did the drone fly? So that means we're looking for this leg right here. So in order to figure that out, we're just going to do, right, that would be the adjacent side because it is next to the 35. So that's going to be cosine. So cosine of 35 degrees is equal to, right, adjacent over the hypotenuse, 1300. So then we multiply both sides by 1300. And you're going to get that the distance you go in the east is equal to 1300 cosine of 35. At this point, we just plug it into our calculator, and you're going to want to make sure that your calculator is in degrees as opposed to radians. So if you have just a regular calculator, it'll usually say either an R or a D somewhere on the screen. And if you have kind of a fancier calculator, you can usually go under mode or math and be able to find that to change that. So you'll know if you type this into your calculator right now and you don't get right, 1300 times by cosine of 35 degrees. So if you don't get 1000 if you don't get 1065 meters, then yours is probably in radians and you're going to need to figure out how to change it into degrees. Now to find out how far north you went. So since this is the opposite, you're going to be trying to use sine to do that. So that's going to be um, right, sine of 35 degrees is equal to how far you went north divided by the hypotenuse. So again, multiplied by 1300. And you're going to get to the point where you can just kind of skip that step and go directly to this step where you realize that, this is just going to be 1300 sine 35. You might need to start out with this step the first couple times, but hopefully you can kind of move right onto this fairly quickly. So then 1300 times by the sine of 35, that's going to give you 745.6 meters. All right, next problem. A cannonball is fired at some angle with a velocity of 50 meters per second. If Vy is equal to 28 meters per second, find theta. Okay, so we should probably draw ourselves a little picture here. "50 meters per second. This is, oops, 28 meters per second. So we would like theta. Okay. So, because this is your Vy, right? So with that, we have the opposite and we also have the hypotenuse. So that means we're going to be using sine. So we go back to, right, sine. In this case, we don't know theta, so I'm just going to leave theta as theta is equal to opposite, which is 28, over adjacent, or over hypotenuse, sorry, which is 50. So I know that sine theta is equal to, I'm just going to go ahead and do 28 divided by 50, 0.6, So here's how you handle this, right? You have sine theta is equal to 0.56. So you're trying to get at theta. So what you're going to do is you need to unsign theta, right? Theta has been signed. So you need to undo that. In the same way that if you had two numbers that are multiplied together, you divide them, or two numbers that are added together, you subtract them to undo it. We have two numbers, right? We have theta, which has been signed. We need to unsign it. And the way that you unsign something is you inverse sign it. And whatever you do to one side, you have to do to the other. That's just how math works. So we have to inverse sign both sides. So let's see here. It's a little zoomed out, I think, but right, there you go. So when you inverse sign sine, you just get theta. It undoes it. So you get theta is equal to the inverse sine of 0.56. This is just a button on your calculator, so you find that inverse sine, little -1 there, and 0.56, and you get that theta is equal to 34 degrees. There we go. Okay, last one here. Find the x. So there's a couple different ways you could do this. You can use tangent, you could use Pythagorean theorem. Let's do the Pythagorean theorem just for fun, but right, you could use tangent, you could use cosine, so lots of different things you could do. So let's just do the Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared, where a would be one of the sides of your triangle, b would be the other side of your triangle, and c would be the last side of your triangle. And we don't use this very often, um, but you could do it this way. So a squared, or I guess let's say vx, since that's what we're really looking for, vx, which would be this side, vx squared plus 28 squared is equal to 50 squared. So then vx squared is equal to 28 squared is, let's see here, oh, not equals, sorry, plus, still plus 784 is equal to 50 squared, 2500. So subtract, you get vx squared is equal to minus, right, subtract that over there, and you're going to get, okay, then square root both sides. So giving you 41.4 meters per second. So that would tell you Vx right there. So if that makes sense, you could stop. If you're just interested in doing this, you could also have used cosine. So you could have done cosine of, this is one way to do it. We're done. Another way to do it would have been to do cosine of, now we know this is 34 degrees is equal to Vx over 50. So 50 cosine 34 is equal to Vx. And just to double check, right? 50 times by the cosine of 34. 41.5, 0.41, yeah, 41.5. So just slightly different in terms of rounding, but otherwise, right? See, it's the same. You also could have done tangent. So these are all options for how you could have done it. Tangent of 34 degrees is going to be, tangent is opposite over adjacent, so that would have been 28 over Vx. You move the x over here, it's going to give you Vx tangent 34 is equal to 28, and then divide the tangent over, so Vx is equal to 28 divided by tangent of 34. And if you type that in, you should get. So these are all ways you could have done it. Obviously, whichever one you like the best works. And sure enough, again, 41.5, so 41.5. So either one would work, whichever one makes the most sense to you. Okay, thank you for watching.